Now that we have our building blocks, today we're going to take a look at measuring segments, finding distances, finding midpoints, lots of different things like that. We're going to begin today by looking at how to measure segments. This is something most of you have probably done before, so I'm not going to spend a whole lot of time on it, but I do want to go through some of the mathematical ways that we look at this. So here we have a number line, and on that number line we have 4 points, S, T, U, and V. The question that's being asked here is how long is segment ST? So one of the ways we can do that is just by counting. So we have 2, 4, 6, 8, 10, and 12. So we can say that that is 12 units long. Another way that we can do it is to set up a subtraction problem. And when we do this, we have to kind of be aware that what we are doing is we're measuring distance, and distance is always going to be positive. So in order to ensure that we always get a positive answer, we set it in absolute values. So we could say that segment ST is equal to the absolute value of S minus T, or we could say that it's the absolute value of T minus S. The order here doesn't matter because we're going to take the absolute value. So if I did S minus T, then I have negative 4 minus 8, which is going to be negative 12, and if the absolute value of a negative is positive, so I have 12. If I do T minus S, then I have 8 minus negative 4, and when I take the absolute value of that, again, minus and negative is like I'm adding, so 8 plus 4 is still 12. So again, the important thing here to remember is that distance is always positive. Always, always, always. Now we're going to look at equal versus congruent. You all are used to seeing equal, right? We have two numbers that are the same amount, so we say like 2 equals 2. Okay. We're used to this equal sign here. We're going to be looking at congruent in geometry as well. So for a congruent, it's an equal sign with a little tilde over the front. The important thing here to remember is that numbers are equal. Okay, so that means they have the same measure, they're the same length. Okay, numbers are equal and shapes are congruent. So congruent is used whenever we're talking about a shape. So we would not say that segment AB is equal to segment BC. Okay, we wouldn't say that because we're talking about the shape. We could say that the lengths are the same, so the measure of segment AB is 4 and the measure of segment BC is 4. We cannot say the shapes are equal. Shapes are congruent. Okay, so shapes are congruent, measures or distances, numbers, are equal. We have two terms now. The first is midpoint, and a midpoint is a point that divides a segment into congruent or equal segments. Right, so they're going to be the same measure and the same shape after they're split up. So when we look at that, in our picture here, we have A as the midpoint of segment CT. So I would have a segment drawn, and we would have point C and point T are our endpoints. And then we would have a midpoint, which would be exactly in the middle, and that would be point A. Now we have a special way to show that pieces are congruent in geometry. If we're looking at a line segment, all we have to do is draw a little hash mark on each of those lines. So that means that segment CA and segment AT are congruent. Okay, so we could say that CA is congruent to AT. And those are segments. Okay, that's what the midpoint does. It breaks it into equal lengths segments or congruent segments. The next piece that we have here is a segment bisector. And a segment bisector is just a point, line, or ray that cuts a segment into two congruent or equal segments. So a segment bisector is going to go through that midpoint that we just drew. So let's look at a picture here. We have KE is the segment bisector of JO. So if we had to draw that, we're going to start by drawing our segment. So here I'm going to have point J and point O, that's our segment. And for KE to be the bisector, well, we're going to draw that ray, and that ray is going to have to go through the midpoint of this segment. There are several different ways to draw this, but we're just going to say that we've got this point is K, that's going to be the endpoint of the ray, and the ray goes in the direction of E. So now we have ray KE is the segment bisector, meaning it cuts segment JO into two congruent pieces. So we, for our picture, would draw these little hash marks to show that they're congruent, and again that would mean that JK is congruent to KO. Now let's look at an example problem here. So we've got a couple different ways of looking at this problem. It says O is the midpoint of segment DG. So we've got, like I said, a couple different things that we can look at here. Some of them might be helpful, some may not be helpful. So I always like to think of, what does this mean? Well, if O is the midpoint, that means that the two segments, DO and DG, are going to be congruent. All right, so we've got that DO is congruent to OG. Okay, so we've got that those segments are congruent. Well, if the segments are congruent, that means that the measures, the lengths, are also the same. So we could say that the length of DO is equal to the length of OG. Now all we have to do is fill in the lengths with what was told us in the problem. So we've got that DO is 6x minus 7 and OG is 5x plus 1. So for DO, that is 6x minus 7, and OG is 5x plus 1. And now we have an algebra problem that we are used to seeing. Okay, so we would subtract 5x from both sides here. On the left side, 6 minus 5 leaves us with just 1x minus 7. And 5x minus 5x cancels, so we're just left with the positive 1. So the next thing that we would do is add the 7 to both sides. And we get that x would be equal to 8. So we know what x is. But our problem didn't ask us to tell what x is. Our problem wants us to find dg. So when it says that, it's asking us to say how long is this entire segment. Well, we know what x is, so we can use that to help us. Because if we look at part DO, DO is going to be 6 times x minus 7, and OG is going to be 5 times x plus 1. Now, if we add these two pieces together, DO plus OG, then we get the entire length of DG. And now that we know what X is, we can just plug that number into our problem to figure out this solution. So if X is 8, I can come in and plug that into my equation here. So we've got 6 times 8 minus 7. That's going to be DO, and OG is 5 times 8 plus 1. So 6 times 8 is 48. 48 minus 7 is 41. 5 times 8 is 40, plus 1 is 41. And look at this. Remember we said that those measures are equal because it's the midpoint? Well, 41 and 41, they're the same thing. We just proved that we actually found the midpoint. So we're going to add those two numbers together to get the entire length here. So that's 82. So DG is equal to 82 units long. Now we're going to take a look at some coordinate geometry. So when we're talking about midpoint and distance in coordinate geometry, sometimes our life is going to be pretty easy in that we can just kind of look at the picture and count to figure things out. So on the left side here, I've got A is at negative 5, 3. Remember that this is an XY coordinate pair, in case you've kind of forgotten that a little bit. So X tells us side to side, right? That's our X-axis, and we've got our Y-axis. So we're going to go back 5, 1, 2, 3, 4, 5, and then up 3, 1, 2, 3, and this is going to be point A. And B is at negative 1, 3. So we're going to go back 1 and up 3 to get point B. So here we have segment AB. Now if we wanted to find the midpoint of that, well, let's find the middle. How long is AB? So AB is, remember we could subtract because the y's are on the same, it's a straight line, we're just going to look at the x's. So we could say that from A to B is 4, half of 4 is 2. So if we go 2 from either A or B, we'll get to the midpoint. So we've got 1, 2, this is going to be the middle of that line segment. So the midpoint of AB, well, that point is going to be right there. And that point is negative 3, 3. So that's pretty straightforward and easy to find. And if I wanted to find the distance of AB, again, all I have to do is say what's the absolute value of negative 5 minus negative 1. So negative 5 minus negative 1 is positive 4. And that's the distance of AB. Or, like I said, we could have just counted. We've got 1, 2, 3, 4. So the entire thing is 4 units long. So that's the easy way for coordinate geometry. But that isn't always doable. Let's look at the next case. Right, so in this case, C is at negative 6, negative 5. So we're going to go back 6, 1, 2, 3, 4, 5, 6, down 5, 1, 2, 3, 4, 5. And if my counting is right, that's going to be point C. And point D is 7, 3. So we're going to go forward 7. 1, 2, 3, 4, 5, 6, 7. And up 1, 2, 3. And this is going to be point D. So before, our 2 points were horizontal from each other, or if they were vertical, our life is pretty easy. But when we have a segment kind of like this, our life is a little more complicated. So how can we figure out the middle of that and the distance of that exactly? We don't want to just guess, we want to actually find those numbers. Luckily, we have some formula to do that. So the first one we're going to look at here is the midpoint formula. So in both of these formulas, we are looking at 2 different points, right? So our 2 points we're going to call x1, y1. Okay, that's our first xy coordinate. And our second xy coordinate is going to be x2, y2. So we have 2 points. So if we have those 2 points, we can use them in these 2 formulas that I'm about to give you. The first one is the midpoint formula. Our midpoint formula is x1 plus x2 divided by 2, and we're finding a point, so that's our x coordinate, and our y coordinate is going to be found by doing y1 plus y2 divided by 2. That's going to be our midpoint formula. Now, let's look at the distance formula. It is a little bit more complex, and it's actually derived from something called the Pythagorean theorem that we'll get to look at later. So our distance formula is going to be the square root of everything I'm about to tell you. So the square root goes over all of this. So it's the square root of x1 minus x2 squared plus y1 minus y2 squared. Now will give us the distance. Now we're going to take a look at how to actually work this out. Now I'm going to find the midpoint and the distance of segment ME. So we're going to call our M coordinates our 1's. So I'm going to have x1 is -6, y1 is going to be 4, and E is going to be my 2 coordinates. So x2, y2. So anywhere I see x1, I'm going to plug in -6. Anywhere I see x2, I'm going to use 5. And the same thing for the y's. So now let's take a look at using our formulas to actually compute these values. So for my midpoint, it is x1 plus x2 divided by 2 will give me my x coordinate, and my y coordinate is y1 plus y2 divided by 2. That's a y. So now, again, all I do is I fill in the blanks and do the math. So looking at my numbers here, x1 is -6 plus 5 divided by 2. And then for my y coordinate, I've got 4 plus -2 divided by 2. So working this out, -6 plus 5 is -1 over 2. So -1/2. And my y coordinate, 4 plus -2 is +2. So that's 2 over 2, which is just 1. So my midpoint is going to be at -1/2, 1. Let's plot that and see if it looks correct. So -1/2 means I go back 1/2, and then I'm going to go up 1. So back 1/2, up 1 will put me right here, and that's my midpoint, so we'll call it, let's just say A. And looking at my picture, it does look like that would be in the center of my line segment, if I could draw straight. So now let's go look and figure out what is the length of segment ME. So how long is it going to be? To do that, we will use our distance formula. So, the distance formula, we have the square root of x1 minus x2 squared plus y1 minus y2 squared. So that's how we're going to find the distance. So now we just plug in the values and crank out the answer here. So x1 is -6, x2 is 5. So we've got -6 minus 5, and we're going to square that, plus y1 is 4 and y2 is -2. So y1 is 4 minus -2 squared. And we'll take the square root at the end of all this. So I'll leave the square root off while I'm working, but we'll do that at the very end. So -6 minus 5 is 11 squared, plus 4 minus -2 is 6 squared. And we're going to do the square root of that. So 11 squared is 121. 6 squared is 36. So 121 plus 36 is 157. Now 157 is prime, so there's nothing to simplify. So I would just say that ME, the distance, is equal to the square root of 157. Now I'm going to leave you guys to try some of this on your own. As always, if you have questions, don't hesitate to contact your teacher, and we'll do our best to get you some help. Have a good evening.